Good afternoon to one and all present here. Charles Dickens, a famous writer, once wrote, "The sun himself is very weak when he first rises early in the morning, but slowly he gets courage and strength as the day gets on." With such positivity, let us begin the third session for the day. We have Dr. Ferdy Kiros-Kenlas, sir, from Oman as our resource person for this session, titled Melding Artificial Intelligence and Big Data. I'm happy to introduce Dr. Ferdy Kiros-Kenlas, who has 14 years of teaching experience in various colleges and universities in and around places like Philippines, Ethiopia, and Oman. He did his Master of Science degree in the field of Big Data from Bulacan State University. He did his research in IT project management from Technological University of Philippines. Predominantly, he is a Microsoft Certified Innovative Educator. Also, he is an Associate Fellow of United Kingdom's Higher Education Academy. Currently, he is working as an Assistant Professor in the Department of Computing, Muscat College, Oman. His fields of interest include data science, artificial intelligence, machine learning, software engineering, and network engineering, also IT project management. We are very happy to have such an eminent personality amongst us today. We welcome you, sir. This virtual session is all yours. Over to Dr. Ferdy, sir. Thank you.
Thank you for the warm introduction. Can I have the permission to share my presentation? Okay, thank you so much. Can you see my presentation clearly, ladies and gentlemen?
Yes, sir, it is visible.
Okay, thank you, Ms. Anish Fatima, for the warm introduction. And on behalf of Muscat College, I would like to thank and congratulate Sri Krishna College of Engineering and Technology for this wonderful one-week international faculty development program on the artificial intelligence, machine learning, and genomics. It is really an honor to be part of this event. Of course, this event is not possible without the efforts of the Department of Electronics and Communications Engineering of the same institution, through the leadership of Dr. S. Sophia, the head of the department, and of course with the initiatives of Dr. Sasi Priya and Dr. Selva Kumar. I'd like also to extend my gratitude to Ms. Priya for the technical assistance and the fervent communication made recently. And before I start my presentation, I would like to extend the greetings from my mentor here, Dr. Rashmi Krishnan. She wants to say hello to Dr. Janet, our principal. Ladies and gentlemen, good afternoon. Once again, good afternoon. This presentation is divided into 3 parts. So the first part talks about the essentials of big data, its historical background, evolving definitions, nature, and what lies ahead of it. AI and also machine learning and its relationship to BD will be discussed as well. Also, all of us attending in this event would like to contribute to the body of knowledge through research. That's why I took a few topics on research trends involving big data and AI. So these key concepts are very crucial and must be totally understood before we go with the tools necessary for us to be able to dig more from big data. So we know for a fact that tools are useless if you don't know where to apply them. And the second part deals with big data and AI applications and tools, wherein we're going to cite some research papers utilizing AI for BD. and we will talk about some means on how to store, handle, and make the most out of big data. So the last part of the talk will take only a few minutes of your time, and we will talk about the challenges of big data, which again means for all of us opportunity for us researchers. To begin my presentations, I would like to give you the classical question. Whenever we start a class in our information systems 101 or database management systems classes, we as teachers and we as students in the past, we start rolling the class with this question, right? Which I call the classical question, focusing on the differences between data and information. At the end of the class, you could have around 15 differences based on the categories. So you could discuss the differences based on descriptions, the format, the representation, the meaning, the interrelation, the feature, so on and so forth. But actually, if we are going to summarize all of these differences and definitions that we are asking and giving our students, we could actually summarize it into this quotation. You cannot have data without information, but you cannot have information without data. All the differences, the discussions, the definitions, the comparisons that we are going to make will be summarized into this one particular quotation. But today, we are no longer talking about with data and information alone. You will know it later as I progress with my discussion. We are now talking about big data. So if we have big data, there is this question that lingers in our minds. If we have big data, does it necessarily mean we will have big information also? Maybe yes, or maybe no. Who knows, right? So maybe one of these days, one of the attendees of this webinar, of course, I'm excited to read it in the future, you will coin the word big information. Who knows, one of the attendees in this webinar. So, but what is really big data? Actually, there are varying, or may I say, evolving definitions of big data. The definition of big data is not fixed, and it keeps on evolving because we know for a fact data itself is evolving. That is why I have cited 3 sources in this presentation. You will see there are slight differences, but the essential terms which I highlighted for emphasis will give us the big picture of what big data is all about. So the first and second definitions talks about the nature and the way it is being produced. The last one talks about the structure and the usefulness or potentials of BD as denoted by the word mind. Here comes data mining, which is another good topic to talk about or to be discussed. Data mining means getting something from something. So I would like you to pay your attention to the phrase difficult or impossible to process using traditional methods. So data, as it evolved to big data, there is a must to go beyond the traditional database management approaches and processes and tools that we have used in the past to convert data into meaningful and useful commodity, which is, we know, information as being discussed in the previous slide. On the middle of this presentation, we will enumerate and have the overview of the advanced tools and techniques in handling structured, semi-structured, and unstructured data. In the big data concept, ladies and gentlemen, we are no longer pegged by rows and columns, fields, and what they call the tuples, unions, so on and so forth in the traditional database system context. But mostly we deal with unstructured data. So our main task is how do we handle and produce gold from all these types of data? And actually what makes challenging is the volume and the rapid changes in big data. So big data means big work. That's why you will have an idea why in this webinar the title is Melding Artificial Intelligence and Big Data, because big data means big work. But what makes BD really big? As I have told you earlier, BD has evolving definitions. A couple of years ago, maybe in the early 2000s, BD is characterized by only three dimensions actually. I would like to cite Mr. Doug Lani for this. He's the one who coined the 3 V's of big data. So in the distant past, big data was categorized or characterized by these 3 V's. We know them, right? Volume, variability, so on and so forth. But if you will notice, this keeps on changing. Before we have the 3 V's, we have the 5 V's, but now we have the 6 V's. So it keeps on evolving, as I've told you earlier. But for me, as an educator and a researcher as well, what makes BD useful is the last V, which is veracity, the quality of the data. This is our main focus, the quality of the data. Later in the succeeding slides, we will know why I predominantly incline to veracity as what makes BD useful. I have cited the 3 major surveys conducted by 3 major IT organizations about the sources of BD. All of these surveys agree that BD comes from streaming data from the Internet of Things. So this is another fertile area for research. That's why you will see some topics later on. We have melding IoT with BD, melding machine learning with BD, because these are allied areas or fields of big data. And these IoT devices, we know them, with the advent of technology, we get many things from different gadgets like smart cars, your wearables, so on and so forth, and your other equipment. And even government nowadays are opening their databases for public access of the available data. And also the typical ones, the data coming from databases from our suppliers and customers, online buying and online selling. But there is this one thing, all of these surveys agree, although the figures might be slightly different. We know surveys, they have slight differences in the numbers, but the thought will be the same. 90% of BD come from unstructured data, which is majority of it come from you and me. How? Via social media. So it means that social media accounts partake a lot in the BD. So it means all of you and me are participants in supplying a lot of data in the BD pool. But let me leave you a challenge, ladies and gentlemen. Is our contribution via social media useful? That's my question. Meaning, at the end of the day, can we dig something or can we mine something from our contribution to the BD? So that's another good area for research, because we know for a fact nowadays that in the social media world, the proliferation of fake news is mostly the concern of more people, especially when you go with a sentiment analysis. So, and this data, especially on the social media, it keeps doubling every year. It keeps doubling every year. So it means that big data will stay, if not for good, but it will stay for a long time. Meaning big data is a fertile area for research for our students and for all of us also as educators. So why do we have to deal with big data? In the distant past, let me just quote Mr. Bellinger's model, which is proposed in 1997. look at how data evolved very fast. In the past, our major concern was just to convert data into information, or actually the top of the pyramid is to convert data into wisdom, right? That was because we have data as the starting point of the process. But this time we are no longer talking about big data. I mean ordinary data. We're talking about big data. Do you think wisdom will be still on the top of the pyramid as the main goal of processing data? Let us see. There's another model proposed by Carpenter and Kennedy in 2004. Look at the top of the pyramid. It's now overpassing wisdom. They're now focusing on vision. This is the model proposed by Kennedy, which is in 2004. Maybe during this time, big data is starting to be introduced. And if you will see on the model proposed by Carpenter and Kennedy, they are now focusing on data handling technology systems. Here comes, little by little, we are now introducing artificial intelligence into the scenario. And not only that, from vision, we are now trying to generate decision-making, good decision-making process. That is why, if you will see, organizations are benefiting a lot from big data, because having more data means having more knowledge, right? And with this, they could generate competitive advantages over their competitors. That's why, if you will notice, most white papers and researches nowadays, especially in the management science area, they are now focusing on researches on how to make data-driven decisions. This is now the focal point of research in the management side. How to make data-driven decisions, of course, driven by big data and AI. So let me just share to you some quotations before I proceed with the main topic of my discussion. I would like to share to you some quotable quotes, as I call them, from Sherlock Holmes. He says, "It is a capital mistake to theorize before one has the data." I agree with this very much. And maybe this one is, it sounds like a joke, but for me, it makes a lot of sense. From Sir Edward Demings, he says, "In God we trust, all others must bring data." I agree. And according to Charles Babbage, "Errors using inadequate data are much less than those using no data at all." And from the management perspective, let me quote Peter Drucker, a management guru. We know him very much. "What gets measured gets managed." All in all, summarizing these quotations, data is a resource, much like water or energy. So this is from the US Chamber of Commerce. So fact number 7, they consider now data as a resource. That's why we coin this what we call data economy. So most countries in the world are now focusing with the data economy, and they consider data as a resource. The more you have, the more competitive you will be. So is having bigger enough? Actually, the importance of big data does not revolve around how much data you have. We know it, but what you do with it, right? So big data nowadays are being consumed by many organizations like Netflix, Procter & Gamble, for product development. So they could generate insights from the customers' perspectives and attitudes towards buying and consuming products. So from here, they develop their products. And also many companies nowadays, they do predictive maintenance, of course, with the use of machine learning. So they could predict which day or which time of the day a machine will shut down. And from there, they could do some predictive maintenance. And also customer experiences, feedbacks. I think at the end of this webinar, you you will be collecting feedback from the audience to check or to determine their experience in this webinar. And from there, you will draw your future plans on conducting webinars. And most researchers today, they focus on fraud and compliance. There are a lot of researchers I'm reading online when it comes to fraud and compliance. They are using big data and artificial intelligence together to detect fraud. And of course, this is the hot topic, machine learning. These are the areas now getting much popularity when we talk about big data, meaning big data and machine learning or artificial intelligence are two inseparable domains. We have a lot of things connected to big data. That's why nowadays it's a talk of the town. It's the hottest and the sexiest job of the century, as they coin it, because everything now is data-driven. Even innovation is data-driven. So to summarize what I'm saying earlier, this is big data. Big data in its simplest form is useless, but putting something in between, which is analytics. So analytics involves some tools, some algorithms, which is also introducing artificial intelligence here, machine learning, and some advanced or more advanced tools, far advanced than our ordinary database systems. So from there, we convert it into something concrete, which is beneficial or usable for every organization, which is at the end of the day, you would like to produce decisions. So how do organizations optimize the value of big data? If you will see in this cycle, this endless cycle, each phase is actually a fertile area for research. Set a big data strategy for business side, and then identify big data sources. All of these phases were actually good areas for research if you look at each phase, because big data is still on its young status. It's still very young, so meaning it's still really fertile for research. And I would like you to look at the main part, which is big data analysis. And if you will see again, this is a cycle, a repeating cycle. And again, each phase of the big data analysis is again an area for research. That is why I keep on mentioning earlier, big data is a fertile environment, I mean a domain where we could start doing research, not for us only, but also for our students. And not only that, there is a lot of money and funding for big data projects and data researches. If you will see, government and organizations are very willing to spend a lot of money for big data. That is why you will notice most computer scientists nowadays, they have this career shift. They are shifting, and they are now inclining towards big data because money is in there. There is gold, as they call it. That is why data science, or being a data scientist, is being tagged as the sexiest job of the 21st century. Why it is the sexiest job of the century? Because you will see a lot of expertise and skills are required to be a data scientist. And not only that, you have to work with various domains. That's why, in my opinion, data scientists are the sexiest people as of the moment, because everybody are attracted to you. You have to work with a computer science, you have to work with a machine learning expert, you have to work with a mathematician or statistician. And many fields are pointing towards data science as the focal point of the process. That is why they're also saying it is so hard to become a data scientist, because you have to know this hybrid of many disciplines. But we don't have to worry about it, because we have a lot of communities, tutorials, articles, white papers involving the discussion on how to work with data science. And on the latter part of my presentation, you will know some of these tools and how we get the most out of it from big data. Smarter enough. One of the definitions of big data, as we mentioned earlier in the previous discussion, is that we can no longer handle big data with the traditional approaches, right? And even the volume of the data we are working with are far behind the human capabilities to process. That is why we need something which is smarter enough and faster enough to process the data. And here comes artificial intelligence. So you will see we have various definitions of artificial intelligence, but at the end of the day, you will see the highlighted words. It wants to focus on two things. We want to emulate man's capability to assimilate data, but with much skills and accuracy and expediency, and also large amount of data. It means that for artificial intelligence to be effective, it requires huge amount of data to become more intelligent and to act more human-like, as we see in this definition. But artificial intelligence in itself is very huge. Actually, it's very wide. We have to narrow down a bit in the discussion when we'd like to correlate it with big data. Because if you will see, AI itself is subdivided into further domains, and one of it is machine learning. So in this discussion, let me narrow down my talk by focusing on machine learning alone, because these other branches would be good for other webinar topics. But let me just narrow down my discussion with machine learning with respect to big data. So machine learning is defined by this guy, Mr. Dr. Bengio, cited in Fagella, the research of Fagella. It's an application of artificial intelligence. It's a branch of artificial intelligence, actually, to provide knowledge to our computers by feeding them huge amount of data sets, of course, from past observations, and let these machines interact with the world. And we want these machines to produce knowledge and generalize this into a use case, into a new context, and applies this knowledge gain into new context or use cases. That is why when we talk with the research trends in big data, you will see here artificial intelligence is the second area, domain, wherein research is very fertile, you will see. Of course, for the networking people, the communications people, they have their parts in this research collaboration, which is on the security. We have to secure our data. With this avalanche of data we have, so security is a major challenge. So that's why these three major areas in research are now popular. If you will read many researches published online, most of the themes of the researches are focusing on these three major areas. So you will see, as I've told you earlier, big data actually plays a big role when it comes to providing usable inputs to other domains as well. If you will see, big data sources can be coming from these various sources stored on various storages, and we feed it into our artificial intelligence algorithm or programs. And then further, the output of this artificial intelligence can be again stored back to the data storage as another source for big data, or can be transformed into useful decisions and also to be inputs for robotic systems and also for further automations. So this is now the research paradigm when it comes to AI, machine learning with respect to big data. So the research trend, as I have told you earlier, melding big data and artificial intelligence. So what is the niche, or what is the area being shared by AI and big data? So some researchers, they are saying that big data is here to stay, and it's going to get bigger and bigger. As it becomes bigger, the more difficult it could be analyzed and it could be handled. Storing it is not an issue because technology is fast evolving as well. So storing big data is not a major challenge. But the analysis, the processing of this data and cleaning this data are the bigger challenges that researchers and data scientists are facing. That is why the future trend is actually the increased demand for AI. We need more people who are experts enough in the AI field. As we mentioned earlier, AI and big data complement each other, and we need lots of data for AI to be efficient. So according to Nick Ismail, one of the editor of one famous IT website, access to data will be the key enablers as artificial intelligence comes of the age. So it's a race against time, meaning an organization having a lot of data is winning the battle, but it's not only that. The organization which is fast in processing those data will surely champion the battle. So it's now a matter of time when it comes to processing this huge amount of information. So in simple terms, the ongoing AI big data circle is like this. Data is fed to AI. That's it. AI becomes smarter because of the data. And as AI becomes smarter, less human interaction now is needed as AI becomes smarter, as we know it. And because of that, fewer people are required for AI to run. So meaning AI can be autonomous in processing this huge amount of information. And after this, what makes it amusing and challenging is how we program AI to feed this new data it produced to itself. So it means that a lot of area for research. So all of those circles I've made mention earlier are very good areas for research. So AI and BD are useless without each other, meaning BD is useless without AI and AI is useless without BD. But nevertheless, let me summarize the study of Melding and Kasi. So both of them, they agree that AI is creating new methods for analyzing data. We are no longer fixed with just simply doing select from blah, 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 where blah, blah, blah is blah, blah, blah. But nowadays we could make a program that could do that for us, especially for complex SQL queries. And data analytics is becoming less labor intensive. I agree with this. We have plenty of tools nowadays. With the advent of big data, a lot of communities and developers are developing a lot of tools which main goal is to make the processing of this data less labor intensive for human beings. So it is really helpful in analyzing this big data. Not only that, in a matter of seconds or minutes, we could produce the data that we usually do in SQL, and we produce it in months and even in years. But with AI involved, in a matter of minutes or seconds, we could produce this information. But of course, at the end of the day, humans still matter, okay? Because machines, basically, they lack emotions, we know that. And And machines are totally honest, actually. They cannot deviate from the programs we wrote them. Unlike human beings, for situations wherein we face gray areas, humans can adopt. But machines, of course, cannot do that. They don't have the rational thinking. They only follow what we feed them. And AI now also is being used to alleviate common data problems. We can use them to eliminate unnecessary data. Actually, according to most studies, there are a lot of golds in big data, but also there are a lot of wastes in big data. That is why up to 80% of the time, according to some researchers, is being spent by data scientists in cleaning the dirty data before it can be used for machine learning projects. And these are the major challenges organizations are actually facing. Again, it's a very good area for research. Why? Because organizations doesn't want to store this amount of data which is useless at the end of the day. So they want researchers helping them to clean data as it arrives to their repositories or to their databases. So what's the solution? Again, machine learning. So let's create intelligent machines that are capable on detecting redundant rows or duplicate records and even not necessary data to pass through our storages. And one thing I like the most is that analytics using machine learning becomes more predictive more predictive and prescriptive. When I was still a student in the master's and the PhD, actually the focus of AI is to tell us what had happened. That was the main focus of the researchers before. We create AIs to tell us what had happened. They are diagnostics in nature. But nowadays, our focus to AI and ML is that it will tell us what is going to happen. It will not tell us what had happened. It tells us what is going to happen. And even better, it could tell us when this happens, this is the solution. That is why data analytics nowadays, with the integration of AI ML, they are predictive and at the same time prescriptive. They are not just simply diagnosing or identifying problems. And there are a lot of things to be done with AI and big data. We have just simply scratched the surface. We haven't dig deeper with the melding of AI and big data. So let us take some real world examples. This is the second part of my presentation. So let me just give you a real life scenario here. So for those people who are working in the administrative area, especially for the HR people, let's see this situation. It says, I'm selecting from the shortlisted applicants for the MIS manager. So it's a position in the company. We have 3 applicants, so help me to select, please. Applicant 1, applicant 2, and applicant 3. So I've used OMR as the basis for the salary because I'm familiar with this. So giving these 3 people applying for the job in the ordinary setting, it's very easy to select, right? Given this criteria, it's very easy to decide and produce decision-making on this. Case study number 2. I'm shortlisting applicants again for the same position, but this time we are now giving a minimum requirement. So the requirement, the criteria is much stricter than the previous case scenario. Again, same applicants we have versus the criteria we set beforehand. So we have to shortlist. At least one of these 3 people will qualify or will be near to the criteria that we set forth. But according to the HR person, I forgot to tell you we have more than 1,000 applicants in our website. So help me to select, please. Here comes the big problem. So processing 1,000 applicants by merely involving humans, I think will take time. And with the urgency of the hiring process, we cannot, we don't have the luxury of wasting time in doing the shortlisting process. So in this scenario, we have to apply one machine learning algorithm. So there is this one learning algorithm, machine learning algorithm that I like the most, which is CBR, which is case-based reasoning. And I like this for the reason that in this machine learning algorithm, there is an evidence of much human expertise, and it has flexibility as compared to the traditional rule-based approach, the if-else approaches. And this CBR process actually can benefit a lot from our big data storages because it's a cycle. It retrieves from the database and it stores something in the database. That's why I told you earlier, AI takes from BD and AI contributes to BD. It's a vicious cycle, getting from BD and giving something to BD. So that's the relationship that exists between machine learning or AI and BD. So the heart of this algorithm is actually on the retrieval process, which is having some mathematical assumptions I'll show to you later. So CBR is utilizing this what we call global and local similarity calculations. Local means we compare the fields or the attributes, as we call it in our databases, age, gender, salary expected, we compare it individually. And after doing the local similarity or the comparison of each its attribute, we go with the global, the totality. What is the totality of similarity of the use case to the criteria? So the mathematical assumptions of CBR is stated in this way. So you have to deal with some mathematical calculation here. And you could design your algorithm in such a way you could draw from your big data source and process them using CBR. And from there, you could perform the analysis. And from the use case I have given to you earlier, with the 1,000 applicants, we feed this data into our CBR system and let CBR system later on help us to decide which among these applicants have local similarity as per the traits and global similarity as totality to the position. So it's a very useful tool that we could use in processing our big data. And then the reuse, revise, and retain cycles of CBR are again contributory to the big data pool. So after reusing this data, we have to send it back to our database, which again makes our big data bigger. And what makes our AI more intelligent? Because the more data pool or the bigger the data pool that we have for CBR, the more intelligent would be this algorithm. And CBR is actually very good for forecasting and prediction. We could predict the behavior of the use case depending on the trends in the data that we have. Using the similarity measure of CBR, we could predict what would be the attitude, the future attitude of people. So I just want to share with you my research paper on the data mining model for student internship placements using modified case-based reasoning. Actually, this is a proposed model I proposed to the Ministry of Research here in Oman, and we are proposing a collaborative communication platform for students, higher education institutions, and organizations. This is for the what we call internship placement. So we would like to make a collaboration between these three entities, wherein students have the avenue to find suitable internship and organization to announce internship programs and shortlist students from there. So actually, the drive of this study is to help institutions and students to easily identify which skills are required for that specific internship platform, and also let industries to select which students they prefer. In the future, most of the studies, they say most practicumers are absolved at the end of the practicum phases. So what I like the most with CBR is that we could give emphasis on the weights, which attributes are getting more weights. Let's say, for example, one company may give much attention to course and less with the gender and the age, which is not applicable to some ordinary statistical analysis. So this is the use case, and then this is how we query it in our SQL's database. Then we will go with the results. Then after this, we do the comparison. So if it is matching, it should return 1. If it's not matching, it will return 0. So meaning the return result is between 0 to 1 or 0 to 100%. And for the other attributes, you will see student A is 75% similar when it comes to the age, and the GPA is 57% similar with the criteria set by the organization. So this is a very simple and yet sensical approach in applying applying machine learning with big data. So generally speaking, as I've told you earlier, at the end of the entire process, student 1 is 82% and student 3 is 82% similar with the criteria set by the practicum company. So they have chances to be placed in the practicum, and lesser with student 5 and the student 4. So this is the example of how we apply machine learning to the big data. So there are useful tools that your students can utilize when you work with CBR. So we call it the free CBR from the sourceforce.net. You can download it using this link. And there's also one research paper, and it is utilizing fuzzy logic. So we use fuzzy logic in this case as the enabler of the big data, meaning we are recording whatever the sensors are reading, the temperature and the soil moisture, so on and so forth, and the variables in the study. And we store all of this to the database. And after this, if one of the sensors will fail, we use a machine learning technique to utilize the data we saved from the trends. So meaning what we have done is AI to BD and BD to AI. So all throughout in this study, the multifaceted area of this study is utilizing both sides with AI. Eliciting data, we use AI. Analyzing data, we use AI. And we put BD in the middle as the storing pool. So we have, again, another available tool that our students can use when working with fuzzy logic. We have this open source software. The name is Fuzzy Logic. And I think your students in your class are interested with sentiment analysis. So we have this, the famous one, the MapReduce software framework. And I think this requires installation of another Linux-based software, but I'll just be focusing on the MapReduce area. So MapReduce is actually a very good thing for sentiment analysis, actually. So my students in the MSc here in Muscat College, we are using this tool alongside the other tools I made mention earlier when they work with various machine learning and big data use cases. So in the MapReduce approach, what we have done is we feed into our program your text file or any data that you collected. Let's say, for example, you downloaded data from Twitter and you want to know the common words or the posts that people are posting, so you could get that as a CSV file or a text file and feed it to your MapReduce. Then after that, the MapReduce program will split your text into rows, and then after that it will count the number of words occurring in that particular text or your data set. So this is very useful when you do the word counting, when you want to count the occurrences of the words being posted on a certain social media platform. And also you can perform this, let's say for example, you want to do averaging, or you want to make aggregations. You can also do this in the MapReduce program. And don't you worry, we have plenty of tutorials available, and you could get it from the Apache website, the one who developed Hadoop. Okay, Hadoop is containing this MapReduce framework, and even the codes are in there, so your students can work around and experiment on sentiment analysis. And actually, this website is also teaching you how, let's say, for example, if you only want to count the specific words and you don't care about the other words, so you want to clean the data, and let's say, for example, you want to exclude this and only include this. So all of the source codes are available on this website. So it's free to download and to work with. And at the end of the day, it will give you this result. It will count the words that you included in your MapReduce code. So in the master's degree, I am telling my students to go to Kaggle if you want your students to work with real life data sets, meaning real life data. Let's say, for example, you want to know the sentiment analysis with the various USP lines, you can go with Kaggle. Kaggle is a website actually wherein your students can download real life data sets. Let's say, for example, if they are interested with COVID tweets or the social media post about COVID, and then students can go and download from here. And the good thing with Kaggle is that they are updating their data every now and then. So the data that you have downloaded last week is different from the data that you will download this week. So they keep on updating it. That's a very good thing with Kaggle. So this is a very good resource for your students when they work with experimental data sets. And there's this very useful tool, which is Spark. I think all of you are hearing this technology. So we have a versatile tool, which what we call Apache Spark. So most data scientists, they use this because aside from doing SQL queries, as we know from the traditional database management systems, Spark is also offering machine learning tools and also graph algorithms. And it's not only that, it could actually let you connect directly with the data source. Let's say, for example, if Instagram or Twitter will allow you to connect to their repository directly, then you can use Spark's streaming structure. So Spark is a versatile tool. That's why I made a quote in there. I said, we've got it all for you. So everything that you need when you go with machine learning and data analytics, Spark is very useful for you. But of course, you have to know Python very well, because Spark is very efficient with Python. Although it works with Java, but the native language of it is very efficient when it comes to Python. So this is an example on how you write your simple code when you work with SQL. Okay, in this query, you can still use your traditional SQL statements. If you are still migrating from your traditional database systems, you can still apply them with Spark. And also, if you want to perform logistic regression. Let's say, for example, you're doing forecasting. It's also a machine learning algorithm. You can invoke this algorithm, this library in Python. And as I told you earlier, if you want to connect directly with Twitter and you want to get their data and process it real time without downloading them and storing them in your local repository, you can go directly with this. And of course, if you want to represent your work into graphs, you could access this library. So Spark is a very versatile tool when it comes to dealing with machine learning projects. So these are the other things you can do with Spark. Of course, with Python, we have statistics, the traditional. Yes, sir. Anything? Is my voice not heard or what? Because I heard somebody from the audience.
Sorry for the interruption, sir. You can continue.
Okay. Okay.
No, mistakenly. Ramesh, sir. Sorry, Ramesh, sir. Can you please mute your mic? Ramesh, sir. Can you please mute your mic?
எனக்கு பார்த்தோன்னே கொஞ்சம் லேசா மாறி ஆச்சு. அது கொஞ்சம் வாழுதான் கார்த்திக். அதனால சரி பார்த்தேன் ஒரு 10 நிமிஷம் நான் கேட்டுக்கலாம் சார்ட்ட. இல்ல வாழ்த்தனை பண்றோம்னா ஒண்ணு நம்ம தினேஷ் ஒரு அவன் தான் கொஞ்சம் வாழு. தனியா அவங்களுக்குள்ள என்ன வேணாலும் போட்டுக்கிட்டு என்ன வச்சுக்கிட்டு நம்ம ஒரு காலையில திருப்பி கூப்பிடுறேன். காலையில 11 மணிக்கு ரஷ்யா மெட்டீரியல்ஸ் வந்து புக் என்ன கேட்டீங்க சொல்லி கொடுக்குறேன் சொல்லியிருக்கேன். அவரை விடாம ஃபாலோ பண்ணிருக்கேன்.
Okay, I'm very sorry for that. And let me continue with the last part. I think I'll be finishing in 15 or 20 minutes. I'll be finishing this talk, I think. So aside from the machine learning algorithms that we have, Spark Python is also offering advanced basic statistics. Okay, so you could work with advanced statistics. Although we could do statistics with the available tools that we have, but these tools have limitations. They cannot handle, let's say, millions of rows of our data sets. They cannot handle those. Let's say, for example, Excel or SPSS. So they have limitations when it comes to handling the data. But if you want to do statistics with big data, then Spark is very useful for us. And aside from those, I've mentioned earlier, we have advanced artificial intelligence and machine learning libraries. Let's say for classification alone, we have support vector, logistic regression, naive Bayes, if you want to go with advanced sentiment analysis, and also decision trees and forests. So we have plenty of libraries available in Spark, but we just have to have an in-depth knowledge of Python. These are the requirements. So it's a promising software that data scientists or students can go when they go with their data science projects or big data projects. So Apache Spark is available on this website. You could get it from apache.org, the community that developed it, and all the white papers and documentations are also in that website. So what lies ahead? We don't call them challenges, only opportunities. So these are the challenges that we are still facing nowadays when it comes to big data. But then again, we don't call them challenges, but opportunities, good areas for research. So look at this one. New technologies, they keep on evolving. And the problem is that organizations are struggling to keep pace with this and to find ways to effectively store the data. But then again, it's an overlap between IT management and the business management side. And the one I told you earlier is the biggest challenge that not only data scientists are facing, but also organization. So they want to clean the data or to reduce the time in curating and preparing the data before it can be used. So 80% of the process, according to the researchers, are spent on cleaning and curating our data. And big data technology are changing at a rapid pace. I'm also agreeing with this. The one I installed in our library, in our laboratory here in Muscat College for the MSc degree, I was shocked. It was really, I think, 3 versions away from the latest issue. Because the reason for that is security. So as data becomes big, as tools are being introduced, we have to secure not only the infrastructure, but also the data we are storing into it by increasing the level of data privacy and security. And there are a lot of demands when it comes to the technical capacity and human capital. We need a lot of data scientists which are good not only in handling the technical parts of storing big data and curating it, but also with analyzing it, and especially with the artificial intelligence area. That's why I told you earlier, there are a lot of computer scientists, they are now inclining or changing careers, shifting towards big data. So these are the challenges and actually opportunities for us researchers. So that's the end of my presentation. I really intend to finish earlier so that we could spend the remaining minutes for question and answer if there are. Thank you so much.
Thank you, sir. Participants, if you have any questions, you can post in the chat menu, or you can unmute yourself and you can ask the question to the resource person. If you have any questions, please post in chat menu.
So there's a question from Malatipit. He's asking, data scientist designation covers what all? I think I made mention on that in my presentation. Let me just go back into it, I think. So as I've said earlier, data science is the amalgamation of all the other domains. It's a hybrid, as I mentioned earlier in my presentation. Let me just have a course to it. This one, I think. So this data science. So these are the areas for data science that we have to look at. Being a data scientist, you have to be good in statistics, in database and processes, data mining, visualization, and machine learning. And the skills required, you have to be a good public speaker, subject matter experts for the context of the project, programming, and real problem analysis skills, creativity, and also communication. So how is Hadoop related to big data? Actually, I made a talk, I guess, last week with the GMRT, I think, if I'm not mistaken, with that institute. I discussed Hadoop. Hadoop actually is a framework. It's like an operating environment wherein other softwares can be integrated into it. It's like, let's say, for example, Windows 10. It's an operating environment wherein you could install other useful tools like Spark, like Hive, like Pig, like this Apache Spark. You can install it above Hadoop. It's a platform actually, and Hadoop is having this file system that we call HDFS. So the main purpose of Hadoop is to provide a centralized environment wherein all these tools, add-on tools, are being installed on top of it, and store, process, and analyze big data. That's Hadoop.
Hello, sir.
Yes, ma'am.
You were talking about JFSC platform, sir.
I don't hear the question clearly. Can you please type it if it's possible?
Yeah, you were talking about JFSC platform, JFSC logic.
Yes, ma'am.
So there mainly we should code in Java, or if we can just use the library. How is the platform, sir?
Actually, JFASI is a standalone. Software, but you have to write your code. You have to write your code, which is an FCL file. So from there, you have to declare your rules and your source of data, and then from there, you will declare the variables that you are going to use, and then you will run that piece of code that you have done in the command line, and then you will have the required information that you need based on your use cases, of course.
Should I be in Java, or is
Which one, ma'am? In the JFASI logic, you're asking?
Yes, sir. Yes, sir.
Actually, you're not required to be good at Java in the JFASI logic. You're not required to be good at Java because it has its own syntaxes,
Okay.
very near to English.
Okay.
But if you want to integrate JFASI logic with real life projects, for example, for deployable projects, then you have to be good at Java. Then you have to call that executable to run and to be embedded in your Java code. But if your concern is just simply for data analysis part, JFASI logic is enough.
Okay.
And thank you for that question. We have a question from Dr. Shivaji. Will cleaning the effect the qualify of data? Is there a chance of losing some critical details? So we know for a fact that computers, also machine learning, is following the GIGO principle, right? GIGO principle in a sense that garbage in, garbage out. That's why my students here in the masters, before they process the data, they have to clean it first. They have to remove the outliers, the unnecessary attributes, or the unnecessary columns, as we call it in the regular databases. So we remove them. So we apply some. There are some tools that we use. My students are using regression analysis or multiple linear regressions to see if these columns are significantly correlated with the use case they want to achieve. So let's say, for example, in their use case, they found out that age is not contributing to the output they are trying to achieve. They will remove that. They will remove that because it will just simply make the data set very big. And at the end of the experiment, that particular column is not contributory to the output. So that's what we mean by cleaning. So you have to run diagnostic statistical tools or machine learning tools for you to see if this column is really related to, or it has contribution to let's say, for example, you are forecasting. If it's not a predictor of that one, then you have to remove it. That's cleaning. The other one is there's a chance of losing some critical details. The answer here is yes or no if you know your use case properly. So if you don't know the use case properly, and depending on the tool, you might be losing critical details. So I agree with this. You might be losing critical details if you just simply remove columns without doing the necessary analysis before you process it actually. So in the pre-cleaning stage, you have to submerge your data into an algorithm to determine if it is useful or not. Because if you will just simply remove it for the sake of making the job easier, then it's correct. You will be losing critical details in your data. That's why you have to pre-process it first with the applicable algorithms, and then from there, if you found that all of these are useful, then proceed with the next stage, which is the actual running of the algorithm. So anything else?
All right, thank you, sir. Thank you, participants. On behalf of Sri Krishna College of Engineering and Technology, I thank Dr. Petri, sir, for the very informative session. We got many insights about the real trends, the recent trends in big data and artificial intelligence, how both artificial intelligence and big data are related. Also, we got to know about the recent trends as well as upcoming trends in the field. Thanks for the knowledge sharing, sir. Thank you all participants. Thank you all participants. You will get a feedback link as well as the assessment link by 4 o'clock. And tomorrow's session starts by 9:30 a.m. Thank you all. Thank you, sir.
Thank you so much for the opportunity. Thank you so much.